bite.
Ya alili ahad.
I'm so proud of you.
Thank you.
You're doing God's work. Don't make a peep. Wait, give me the napkin. Ah, it burns.
Time for Tintin.
I smelled a blow up.
It's delicious.
This has got me rolling.
Sorry. A little cheese on my hand.
Why are you looking like that?
You better wash your fucking hands after this. You like that? You want a bite? You want a bite? I'll give you a bite.
Oh my God.
Ooh.
Thank you so much.
I'm asking you, where is my destination? If you would kindly point at where I am
pulled
supposed
into
to
your
go.
destination. It said here I was at your destination. It's over. Get out of my car now.
It said
Get
1760.
out of my car now.
Hey guys, and welcome back to my channel. So today, I'm going to be doing vegetarian ASMR. Wait. Hear the R. It's to relax you. ASMR. So I went to the store and I bought a lot of vegetarian stuff like broccoli, lettuce, carrot, drinks, bars, fruits, strawberries, things like that, right? Super. So the first thing that I want to do for you guys is my CO2 pure coconut water. I'm sorry. I wasn't expecting that. Oh, it's a little clumpy. I know I just spit in this. It's nasty. Okay. Right. Okay. It's sparkling grapefruit. You hear that? Damn it. I spilled a little bit on me. I'm a little wet.
Yo, I am dying. Okay, bitch, deep throat. Deep throat.
That is so refreshing. Oh my god, this is really amazing. Next, for all you vegetarians out there, broccoli. Tastes real creamy. Real grassy.
Oh my god, I am dying, yo. Dying.
Like a tree. Real earthy. Okay. Right.
Why is he doing that? Oh my god. Oh my god. This is gonna be dying. I am probably no.
So good. We have grapefruit.
That sounds so disgusting. Oh my god. Oh my god, that sounds so disgusting. You fucking that shit up. Fuck it up. Fuck it up, bitch. Oh my god.
So delightful. Strawberries.
deep throat. Oh my god. Ooh, bitch, like, bitch, did you just eat that all? Bitch! Oh, I'm done. I cannot.
Fresh. We have some
God.
bars. It's so satisfying. It smells like sweaty feet. Right? We're gonna eat it. It's really dry. Tastes like dirt. So makes me feel like it's like nature. We have a car. I don't want to heat the bottom. Okay. That's all, folks. That's all, folks. I'm just like,
This is gonna be rolling. Oh my god, this got me
I'll say
rolling.
this.
Oh my god, yo. Oh my god, no, don't do it. Don't do it.
Sorry. Have a lettuce. Alright.
Oh my god, bro. Bitch, you crushing? You crushing? Yeah.
Well, that concludes.
Stop it! Bitch, stop, no!
That concludes. That concludes our ASMR. So remember, God only made one you. And if you don't be you, then nobody else will. Cue the music.
Fuck it up!
The hosters, he was risque, homework, nephew, homework. Stay down, come up.
Yo, I am dying. Yo, I am dying. What am I doing? Oh my god, this got me happy. Rolling. Oh yeah, I turned on it. Oh my god! Disgusting! Oh my god! Yo, this is disgusting! Oh my god, this is disgusting! Oh my god. This shit got me rolling. Oh my knees, like. Bitch, why your head look like that? No, don't eat the pickle. I'm highly disappointed. It's just people, they always doing some shit and pickle people. Yo, I am dying. Why they say don't put super glue?
In today's video, we're going to see what happens when you try to boil super glue, and we'll try and answer the question, is super glue flammable? Super glue is super interesting stuff. Also known as cyanoacrylate, this glue works to form a very quick and strong bond. Most people have only used or bought super glue in some very small quantities. It often comes in tiny tubes that only have a few drops in them. But we've gotten our hands on an 8-ounce container of super glue. The first thing I want to try is heating it up. I want to see if you can boil super glue, and if you can, what happens to it. Here's the basic idea. We're going to empty 8 ounces of our super glue into a saucepan that won't be used for anything else, then boil it on a hot plate. What do you think is going to happen? Will the super glue just evaporate? Will it catch on fire? Or do you think it's going to explode? We're doing this outside today because even if you aren't boiling it, super glue puts off some pretty powerful fumes. It can irritate your throat, your eyes, and your skin. And I figure that when we heat it up, those fumes are going to be multiplied by quite a bit, and I really don't want that in any confined space. So we're in a nice open area. We've even got a fair breeze passing through, which should make it easy to avoid breathing in any of these fumes. First, a very quick test as to the stickiness of super glue. Got it on my gloves, and my gloves are now glued together. Peel apart. It does the exact same thing if you get it on your skin, but it really hurts to try and peel it apart. This much super glue is actually fairly dangerous because if this got on you in any large quantities, it could require medical intervention to get it off. Like if this were to spill all over my clothing, it could stick my clothing onto my skin and I wouldn't be able to pull it off. So I have to be very careful not to get any of this on me. This stuff is amazingly thin and clear. It really just looks like water. I don't want to waste this super glue, but just because I've never actually seen this much super glue out of a container in one spot, I gotta play with it a little bit. It feels slightly slimy, oily on my fingers right now, which I'm sure would glue together if I held them. You can see little bits where it's thin, starting to glue as it dries out. It just feels like you know, water or thin oil. It's pretty nuts. Let me see if I can glue my glove onto this rock. I am not holding onto this rock. It's holding on to me, really. The glue hasn't completely cured, so I can probably pull my fingers apart and make it drop the rock. Let's try it. Well, kind of. All right, since I don't want my movement permanently arrested, I'm gonna take this glove off and put a new one on. We're ready to turn on our stove, but I've got one more thing I want to do just to protect everything before I do that, and that's just to put a sheet of foil over our hot plate. In case the super glue boils up and out or something like that, I don't want to spill super glue all over this plate, so just one piece of foil going across the top, that's it. All right, let's turn this on to low. The breeze we've got going on might make this take a little bit longer than normal. I'm not sure I'll be able to tell the difference since I've never boiled super glue before. I don't even know if it will boil. It might just heat up or light on fire or smoke a lot. We've got fumes. I don't think I can call that steam since I don't think cyanoacrylate glue contains any water, but it's vapor of some kind. Yeah. Oh boy.
All right, I'm busy
Jackass.
today, so come on, you gotta hit me with it. What do you go first? What's your joke?
I bought some shoes from a drug dealer. I'm not sure what he laced them with, but I've been tripping all day.
Okay, David, give me something. Come on, man.
I found this humorous.
Put the bone on the table. Angela, come on, save me.
Sorry, I'm reading this post on anti-gravity. It's impossible to put down.
Are you using puns?
Dated puns, too.
We don't use puns. We make jokes.
Oh, that went from 0 to extremely powerful in no time at all. Whew. Good thing we are not doing this indoors, or I'm pretty sure the whole indoors would be like that. Ah, it's still in my eyes. It got me again. I was upwind. We've got some good white vapor coming off of the saucepan with the super glue in it, but I want to try turning the heat up. It's not really changing much. It's been doing the same little bit of vapor thing for like 5 minutes now. I think it needs more heat.
Cool.
Hey, what's up guys? Thanks for joining us today on The King of Random. Batteries are everywhere and we use them in all sorts of stuff. And a lot of the time they come with warnings saying to make sure that you dispose of them properly and how they can be dangerous if you misuse them. Well, today we're going to take this group of batteries and we're going to run them through a series of destruction tests to see what happens if you stab them, cut them open, smash them, or even burn them. So let's get started. Not too long ago, I tried using a nail to slightly dent a battery to help balance a homopolar motor. Well, now I'm going to see what happens if I take a nail and drive it as far as I can into the battery, not just denting it on the top. Oh, it's leaking something already. There's liquid coming out of this battery. Well, that's a good start. Let's keep driving the nail and see what keeps happening. I'll be honest, I didn't really think that the nail was going to be able to drive this far into the battery. That is pretty much all the way through it. And it is still leaking. We've got this liquid leaking out, which I believe is potassium hydroxide, which is supposed to be fairly irritating if you get it on your skin. So try and avoid touching this stuff. Our battery is also getting pretty warm. I'm gonna hit it with this little laser thermometer. 120 Fahrenheit. Battery is getting quite hot now. As a comparison, if I take a scan of the block of metal next to it, that's at 65. The battery is at 135, still heating up, pretty warm to the touch. 136. I'm just gonna stand back a little bit and let it go and see if anything keeps happening to it as it warms up like this. Let's see if I can take an accurate measurement from this far away. It's showing 145 now. Well, if I get closer, it's showing 166. I'm gonna try and pull the nail out. Nail in from the other side. More oozing liquid. Going in at a weird angle here. Let's see if I can straighten this out. Ooh, and since there's a hole, I can now go all the way through. My thermometer is showing that it's up to 100 degrees Fahrenheit. Watch it just climbing in temperature. Our other battery got up to 166 on here, and now we're only hitting 116, so it's definitely warm, but it's not as hot as the other one. Now I've driven a nail through either end of the battery, I think it's only fair that I try and drive one right through the side. It's warming up again. Just hit 100 degrees Fahrenheit. Oh, something just made a fizzle noise. As the liquid inside the battery is spurting out onto the nail, it's occasionally making a hissing sound. It's past 130 Fahrenheit, 140. The orb hissing and bubbling. Seems to be hovering right around 150 now. And once again, we have a battery with a hole running right through it. Holding it still for a couple seconds, it really does start to heat up in my hand. Well, I would say that being stabbed with a nail is definitely not good for batteries. Now, since it should be a fun way to destroy it, and I want a good look at what's inside, I'm going to take a hacksaw and cut this C-cell battery down in half lengthwise. There's our black liquid oozing out. Alright, I've got this black paste just all over the blade of the hacksaw now. Turn this upside down. Keep cutting through it from the other side. Ooh, I think I've got it.
Oh my god, what is
gross.
this?
Well, I've got a gooey paste here and a slightly less gooey paste here. It smells a little bit like ammonia. This paste looks like it's full of little metal flecks. I need to do some research and find out what is inside a battery. This rod is coming from the negative terminal, so this rod clearly goes down into this silvery paste. About the consistency of toothpaste, I'd say, maybe a little bit thinner. It's like really, really compacted dirt kind of texture. Not just this metal shell. There you go, guys, a C-cell battery. Probably a little bit difficult to fit inside your remote control car at this point. Our next method of destruction might not be quite so eventful, but I've always wondered what would happen if you just took two 9-volt batteries and plugged them into each other and just let them sit. I'm sure you're not supposed to do that. Let's find out why.
Freaking ads.
Alright, those are now providing feedback into each other. I'm just going to check with the thermometer what temperature they're getting to. See, they are warming up a little bit at a time. 75. Ooh, some part of the battery is a lot warmer. That's measuring 85. There's different temperatures, different parts. Parts of it are at about 80 right now. Other parts are over 90. Oh, over 100 Fahrenheit now. Yeah, it's interesting. One of our batteries is considerably warmer than the other. This battery is only measuring at about 85 right now. So this battery is measuring in at about 105. Curious. The gloves do insulate a little bit, so it's hard to tell for sure. But I think this one does feel warmer. It's warm enough to cook a steak if you like it rare. Next up, we've got a 20-ton shop press, and we're going to see what happens if we put a couple different types of battery under that and just squish them. We've made contact, now the squishing begins. Ooh, that circle might just bite right into the battery. We've got some stuff oozing out. Good amount of stuff oozing out on the back. Alright, I think that's about as flat as this jack is going to get it. It's pretty squished. I think it actually bounced back a little bit after being squished. You can definitely see some of the innards of it. Now I've got a C-cell battery under here. Let's squish that down and see what happens. definitely deforming sideways, so I'm pretty sure it's just gonna pop out in a second. Or it's just gonna burst and squirt liquid really far. That was exciting. Well, now it really is like toothpaste being squeezed out. That is obliterated. Quite completely obliterated. This smushed C-cell battery is probably just as broken as the one we cut in half. That really just oozed out there, kind of like toothpaste at one point. That was fun. Now for our next type of destruction, I'm going to try hitting a few different types of batteries with a blowtorch. I've got our 9-volt battery, a normal AA battery, and then I also have a lithium AA battery, which does contain lithium and should burn very brightly and possibly with interesting colors. We'll see if it actually burns through to the lithium well enough to ignite it. Not sure if it'll work or not. As you can see, I'm also now wearing a jacket, and that's just for protection in case something burns or shoots hot liquid at me. I just want a little bit more protection. I'm going to start out with the 9-volt. I am nervous doing this, holding it this close to me. Alright, I was a little too nervous just holding that battery like that, so I've now got this system set up so I can just set the torch on the battery and then safely back away. Let's give it a shot. Got a little glowing orange spot. The bottom seems nice and hot, but it doesn't actually look like it's doing too much. Certainly some flames coming out of it. Ooh, oozing out the back. Now it just seems like the whole battery's kind of on fire. Alright, let's turn that off for a bit. That's some interesting colors right there. Sort of a bright glowing smoke for a second. That was interesting. And we've got these smaller piles inside. I didn't think this type of battery worked like that. But I think each of these is a 1.5 volt battery, and then there's 6 of them. Gives us our 9-volt battery power. Let's try it with our other types of battery and see what happens. Well, it's peeling away the wrapper on the battery pretty instantly. It's starting to leak pretty quick. Much faster reaction than the last one, that's for sure. It smells awful too. Ugh. Timber! Let's try our lithium battery. Once again, the outside gets destroyed immediately. Whoa! I think it lit. Okay. And now it's... No, now it lit. Now it lit. That's amazing. That's fantastic. What even just happened? Yeah, look how pink that is. It's magenta colored. It's not a normal fire color. There's still something melting on the back. I don't know what liquid that is that's boiling and bubbling there. Now I just have like this glowing orange, I don't know. It's like glossy on the outside. Inside these lithium batteries, there actually is a strip of lithium metal, and we're gonna see if we can take that out. That's what's causing the bright magenta flames. There we go, that whole thing. So there you have just coils of metal strips inside there, and one of those strips is lithium. This whole wad of, there we go. So this one, I believe, is not our lithium. I don't know exactly what metal it is, probably aluminum. Then here inside our plastic, that is a strip of lithium metal. Very lightweight, like more than aluminum, it feels like. This feels super, super light. Also tears very easily. It's really soft and You can see how easily it wrinkles and everything. This feels thicker than aluminum foil, but it's at least as soft, maybe softer. All right, so let's light this little piece of it off. You can see how magenta those flames are, and then when it really ignites, it gets very bright. Look at that, it's melting into our fire brick. See if I can put another piece of it on top of it. Yep. Really bright. Kind of hurts to look at it, so bright. And it's like the smoke is being lit up by the heat of it or something. That's pretty crazy. There you have it. We've just destroyed a whole bunch of batteries in a whole bunch of ways. We stabbed, cut, smashed, and burned our batteries to see what happens. I can't say I really recommend doing this because then you don't have your batteries anymore, although burning the lithium batteries did look pretty cool. We found that inside the batteries was a silvery paste and a black clay-like substance. Cutting the battery in half really let us see the insides pretty well. A nail driven through a battery caused a lot of leakage, and I'm sure the batteries don't work at all anymore. And lighting the batteries on fire had different effects based on what type of battery. Hey guys, I'm Nate. Welcome back once again to the Dome, and as I hope you know, when we're at the Dome, we do crazy fun stuff. Today our experiment is to find out what happens if you drop a lit firecracker into gasoline. Now, I'm not going to be quite so dumb as to just hold a firecracker and drop it into a pot of gasoline at my feet. I'm going to set up a system so that I can light it, run away, and then have it drop when I am at a safe distance. Firecrackers have a very short, very quick burning fuse on them. So to make this work, I'm first going to attach a little bit of a slower burning fuse to the quick fuse of the firecracker. We'll then tie the slow burning fuse onto a piece of string that's hanging from a stick over our pot. Hopefully when it gets down to where the string is tied onto it, it will then drop, still burning, into our gasoline down below. The idea is that the firecracker will light the surface of the gasoline as it falls in, and then it will still explode while under the gasoline, launching a giant fireball into the air. First, let's just test if lighting the fuse will make our firecracker drop down before it explodes. I'm going to light the top of the fuse and then book it to the doorway of the dome so I'm safely out of range. And as added protection, I've also put in some earplugs because it echoes a lot in here. That actually worked really well. I didn't really think about how these slower burning fuses kind of have a lot of push to them, and that sort of made it spin around. But it still dropped fairly straight down. It still lit off and everything seemed good. I think at this point, we need to try adding gasoline. I have a decent sized metal pot, and I'm going to start by just putting a little bit, less than ½ an inch at the bottom of our pot. I'll light the fuse, let it drop in, and see what happens. I'm not sure what the effect is going to be. It's possible that gasoline will stop the short fuse on the firecracker from lighting, but we'll have to find out. Well, all of the motion from the fuse swirling around made it miss our pot just barely, so I'm going to try and change the angle of the stick so it's a little more right over it and it can't fly sideways quite as easily. Try it again. Oh, well, that's not how I thought that would go. Huh. Wow, that stopped the big fuse. It didn't burn through the string holding it up. It just came untied. Now I'm just going to light this on fire and see what happens. There it goes. I was a little bit surprised when our firecracker and fuse dropped into the gas and nothing lit on fire. I thought the fuse would certainly keep burning and would probably ignite the surface of the gas. That didn't happen, so now, just as a test, I'm going to try lighting a piece of fuse and throwing it right into our pot of gasoline. Not what I expected. It didn't light the gas on fire, and the gas actually put it out. Guess if there's too much gasoline, it loses the oxygen that it needs to burn. I kind of thought these fuses had enough oxygen embedded into them that they could keep burning even if they are underwater, but it doesn't seem to work too well with gas. I think what I'll try now is putting another firecracker into the pot with the gasoline attached to the side so that most of the firecracker is submerged in the gasoline, but the fuse is above it and staying dry. Let's try this out. I kind of have a suspicion I'm just going to light the gasoline on fire. Maybe then if the fire explodes, it'll just spread lit gasoline everywhere, which is kind of what we're going for. Here goes. You lit the firecracker. Go, go, go. It's not exploding. Once again, the fuse went out. I think it was sitting in the gasoline so long as we set up the cameras that it just sort of soaked up. So I'm going to try doing it one more time and just see if I can do it faster. Try and do this quickly. Woo! Yeah! That's what I was hoping for. So, it was already on fire, which I think worked to our advantage. When it exploded, it just sent flaming gasoline everywhere in kind of a fireball, and that was a lot of fun. Well, we want to try and scale this up. That was awesome. I'm going to add a little bit more gasoline, and then I'm going to try and make it so several firecrackers go off. Not all of the gasoline burned up, so I'm thinking we might get like one explosion after another of the gasoline, which would be pretty sweet. I now have 5 firecrackers attached to this piece of tape. So same idea, I'll lower it down so all 5 are somewhat submerged into the gasoline, tape it onto the side of the pot, and then I'll just light the gasoline on fire. I'm not going to try and aim for the fuses anymore. And hopefully we get 5 different explosions. That'd be neat. Tape an unexploded firecracker. Several more unexploded firecrackers in the gasoline. I think when the first firecracker went off, since it was secured to the same piece of tape that the rest of them were, they all tore away from the edge of the pot and got submerged in the gasoline. And I think we've seen that it only works if the firecracker isn't entirely soaked in the gas. So I'm going to try it one more time, getting 5 firecrackers, but each one will have its own piece of tape holding it onto the side. Here goes. Woo! Ah. The fuse burnt. Firecracker did not. Not even all of the fuse burned on that one. I think when the first one goes off, it might splash the gasoline so much that it soaks the other ones, and it gets on the top of them, it gets down inside, and the wicks get hit, and it just sort of stops working. I'm going to say that's the one that exploded. Alright, continuing on the saga of good decisions made today, I'm going to see if I can just light the gasoline on fire, light the long fuse on this firecracker, and then once it's getting pretty close to the quick fuse, just toss it in and see if it happens to work like that. I'm not really hopeful, but it's worth a try. It went out. All right, one more thing I want to try. I have 3 firecrackers, which are all bundled around the same slow fuse I'll try taping this on so that they're only partially submerged in the gasoline, light it on fire, and see if we can get any sort of larger result with that. Here goes. Fuse is lit. I think multiple of them definitely went off. That sounded like a much louder bang. There's like not much left in there. There was a little burning bit that I think was the remnants, but I think at least 2 of them went off, maybe all 3. I don't know if the fireball seems much bigger, but it was still pretty cool. One more thing I want to try as sort of a finale. This is a good idea. Fuse is lit. It worked. I don't have a good way to put that out. Well, there you have it. An experiment to see what happens if we throw a firecracker into some gasoline. We tried to set up where a lit firecracker would fall down into a pool of gasoline and it wouldn't light. We tried lighting the fuse and just tossing it in, and that wouldn't light either. It seems that the fuses on these firecrackers just go out when they have too much gasoline. Hey guys, I'm Nate. Welcome back to the workshop. Today we've got a fun experiment we want to try that was brought to us by a viewer request. YouTube user Ahmed Mohammed says that he is still waiting for us to try mixing negative X with thermite. Well, Ahmed, we think this sounds like a really fun idea, so we're going to mix up a batch of negative X and then a batch of thermite and see what happens when they combine. In case anyone doesn't remember, negative X is a composition we showed you how to make a little while ago, made from ammonium nitrate, ammonium chloride, and zinc dust. With these 3 mixed together in the right ratio, just a few drops of water can cause it to ignite in some bright green flames. Let's start by mixing up the ammonium nitrate and ammonium chloride. You may also recall that it's not safe to add the zinc powder in until you are absolutely ready for it to light off, because once the zinc is added, it can spontaneously combust if there's too much humidity. Our source of ammonium nitrate is these instant cold packs. The pack contains ammonium nitrate beads in a small bag of water and is activated by squeezing and breaking the small bag inside. To start, let's measure off 6 grams of our ammonium nitrate. That seems really small, so I'm going to do a double batch. And now, since we're doing a double batch, we need 2 grams of our ammonium chloride. This is a small brick that you can buy online. It's usually used for cleaning the tips of soldering irons. Let's shave off a bit of it into our cup. That's 12 grams of our ammonium nitrate and 2 grams of our ammonium chloride. Now we need to turn this into an extremely fine powder. There we go. Our ammonium nitrate and ammonium chloride are now well blended together, and I've basically turned them to dust, which really helps the reaction speed, I think. However, this time I am going to try not to leave a large batch of it together after I've mixed in the zinc. If you remember from our last video, we had a little bit of a problem with spontaneous combustion. Once I'm outside and ready for things to start lighting on fire, I'll add the zinc into that mixture, but for now let's mix up some thermite. That's 60 grams of iron oxide. Now we need to add in 20 grams of aluminum powder. All right, there we go. We have all of the components for our thermite. We've got the components for our negative X. Let's take these outside and try a couple different ways of combining them. Now, in case you don't remember how negative X works, let's mix up a small batch of that and light it off using water. Well, it's supposed to be 24 grams, but I think it's just changing with the air moving the paper around. So this actually will be a fairly good-sized batch, but as soon as I've got it mixed up, I'm going to spread it out because I think it is less prone to reaction when it's not quite so concentrated. All right, let's try taking a small scoop of our negative X, pouring it onto our paver stone here. Spread this back out so it's at less risk of igniting, and move it far away from the rest of the negative X. If everything works out well, this should only need a couple of drops of water to ignite. very delayed. Very, very delayed. Well, there is the green flame that we were looking for. I don't know why that took so long to go off. Sets the new record for slowest reaction time with negative X. For some reason, our negative X is reacting a lot more slowly than we're used to, but it is reacting and it is igniting. So I think we're just going to run with it and see if it still works to ignite thermite. We're going to try it two different methods. First, we'll see what happens if we actually mix some of the negative X with the thermite. Can it still get a reaction, or will the negative X be too spread out to really react with the water? Let's find out. All right, now we've got our negative X. Let's mix some of this in with our thermite. Little spot for right there. All right, now let's try dripping some of our warmer water into a little divot I've got in our thermite negative X mixture. We'll just let that sit for a minute and see if anything happens. All right, well, it doesn't look like that's going anywhere. So our next plan is to try mixing up a batch of negative X and just putting it on top of the thermite and then adding some water. Hopefully that will light normally and the heat from it will ignite the thermite. Let's try it out. Now this thermite does, of course, also have the negative X mixed in with it. I'm hoping that won't adversely change the reaction any. But let's mix up our new batch of negative X and then pour that on top. All right, that looks pretty well mixed. I'll try and pour some of this down on top of the thermite. Getting sucked in. Now we're just waiting to see if it starts bubbling at all as it reacts with the powders. Oh, there we go. Well, it definitely lit the negative X off. I don't think that lit the thermite, though. Seem to have some unlit thermite right underneath our negative X. Still really hot. I was hoping maybe that would light off the thermite. All right, now just to be sure, I'm going to try lighting up the thermite with a blowtorch because there is a slight chance that having the negative X mixed in with the thermite has actually changed the chemical formula to something that doesn't really want to ignite. So let's test if it burns normally the way thermite should. All right, here goes. Is that not usually enough to light thermite? Well, just as a test, we tried using our blowtorch to ignite thermite, and I don't know if it was hot enough. So to make sure we're really using the right amount of heat, I'm going to try using our mini solar scorcher, which we know we've used to ignite thermite in the past. Well, it ignited, but it's definitely going slower than regular thermite. There's not even any green in there. There's zinc powder mixed in with this thermite, but no green flame. This is the slowest thermite reaction I've ever seen. Well, I would say that's a pretty good test that shows that the negative X being mixed into the thermite definitely slows down the reaction speed. And since we want a full speed reaction for the test, I went ahead and mixed up a new batch of thermite. I've still got some negative X. We'll try one more time to see if the negative X can light the thermite. There's our thermite with no negative X in it. There's our negative X poured on top. And I'm just gonna put a little bit of thermite sort of overlapping so that maybe it can like burn underneath the thermite and that will ignite. I don't know, we'll see. Now let's try adding some water and see if we can get this thing to go. Even though for some reason it's taking like a minute for the negative X to start reacting to the water. I don't know what's up with that. Oh, faster reaction this time. Something's going. Green flame. Oh, there's sparks. I think it wasn't quite enough. I saw some sparks, and that's kind of what it looks like when the thermite is almost going. It just sparks and lights tiny little iron particles. If I shade it, I think you might be able to see this is glowing orange still in there. That's how warm the negative X got, but it wasn't enough to ignite the thermite. Nice orange glow. Not hot enough for thermite. Which really says something about the solar scorcher, too. Speaking of which, let's light this off with the solar scorcher. Boom. Oh, it cracked right through the pot, too. Wow. Well, there you have it, an experiment seeing if we can use negative X and a little bit of water to ignite thermite. Unfortunately, it seems that negative X does not burn hot enough to ignite thermite. Of course, we also saw that neither does our propane. Hey guys, welcome back. Thanks for joining us today on The King of Random. In the past, we've done several experiments with dry ice, and we've had 2 viewers give us suggestions of other things to try with the dry ice. Daniel Mileage asks, how does liquid nitrogen compare to a cooling bath of acetone and dry ice? YouTube user LikeWoe says, put dry ice in your backyard foundry. So LikeWoe and Daniel Mileage, today we're going to be doing 2 experiments using extreme heat and extreme cold. The first thing we're going to try is using some dry ice and acetone to make a super cooled liquid that you can use for some experiments if you're having a hard time getting some liquid nitrogen. Dry ice is extremely cold. It's approximately 109.3 degrees Fahrenheit below zero. Acetone doesn't freeze until 139 degrees Fahrenheit below zero, so we can put dry ice in acetone. It will super cool the liquid down to the temperature of the dry ice, but it won't freeze. We don't just want to mix the 2 together, so first we're going to use this cup to create a barrier between the acetone and the dry ice. For our first step, let's take a drill and poke some holes in our cup. I've poked a lot of holes into this cup because I want the acetone to be able to flow in and out of it easily. Next, we're going to break up some of the dry ice and spread it all around the outside of the cup. All right, now load these all up all around our cup. Our glass bowl is whining. That's the dry ice vibrating in very small movements all around the glass. Just sounds like it's complaining. The next step is to pour your acetone down into the bowl, and it should fill the cup as well as all the way around the dry ice. Just pour some directly into the cup to make sure it's getting in there. There you go, lots of bubbling going on. I'm going to try adding a little bit more dry ice as well. Some of it seems to have sublimed off from the heat of the acetone. All right, now we have a bath of extremely cold acetone. That's fun. And in the middle, because we have the holes in the cup, we have a spot that doesn't have any dry ice in it, so we don't have to worry the acetone. Oh, that's very, very cold. It actually makes the nitrile of my glove get a little bit stiff just from freezing it so much. Let's see what happens if we freeze a carrot. Please note, never use this cold acetone bath on anything you're going to eat. Acetone is toxic and not safe for consumption. All right, our carrot looks pretty good and frozen. What I'm going to do at this point is take it out and smash it with a hammer to see if it shatters the way we expect a really frozen piece of produce to do. Quickly before I try that, let's make a control by smashing an unfrozen carrot. 3, 2, 1. That kind of exploded a little bit more than I expected it to. Carrots aren't super squishy, so I guess it makes sense. We've tried smashing the unfrozen carrot. Let's see how the frozen carrot handles. Ooh, listen to that. That is not the sound of a normal carrot. 3, 2, 1. Oh my gosh. That is a very frozen carrot. Holy cow. That sent shards. I mean, the unfrozen carrot like broke apart, but this like explode. Listen to that. That's a carrot. That is shattered to high heaven right there. Kablooey. It is ice carrot. Now we know what happens if you freeze a carrot in acetone that's over 100 degrees below zero. Next, I want to try an experiment with a rubber band. When rubber gets too cold, it loses its elasticity, meaning it won't stretch out. But it also means if it is stretched out, it won't contract back in, and that's what we're going to try and do today. What I'm going to do is take this rubber band, fit it on the end of the bamboo skewer, and stretch it out, and while it's stretched, I'm going to dip it into our freezing cold acetone. Let's see what happens. Little bits of carrot floating around in there, but that shouldn't cause any problems. That's probably pretty good and cold already. It's stopped bubbling. Let's take it out and see what happens if I let go of the rubber band. Look at that. The stretched out portion is staying stretched out, and then as it warms back up, it regains its elasticity as it warms back up. This time I'm going to see if I can pull the rubber band out and immediately try and bend it and see if it will break. In theory, it should be able to get cold enough for that, but it might just warm up too fast and I'm not able to get it. All right, let's see what I can do here. There it goes. Snapped a rubber band in half, and now it's already warmed up enough that it's starting to be stretchy again. Let's try that again. Broken. I think at this point, the responsible thing to do is to put the whole rubber band ball in and see what happens.
Look at that. If the camera is having problem to focus, all you gotta do is tap on the image right here, tap on the square, so it could focus. Once it focuses, okay, this one
happens. Hopefully the acetone is getting in between the rubber bands and down into the middle, so it's really freezing it all the way through. All right, let's see if I can take this out and see if it has any bounce left to it at all. I bet it doesn't really have any. That sounded like a rock. Put this back in for just a second in case it's warmed up. Then I'm going to try hitting it with a hammer. 1, 2, 3. Well, bits of it broke off. I did shatter some parts. You can see little destroyed bits of rubber band just sort of sitting around. There are impact marks where the hammer hit, and I think as this warms up, this is going to start peeling away a lot more. As one last experiment with our freezing cold acetone and dry ice, I'm going to see what happens if I pour a little bit of water into it. Genuinely had no clue what to expect here. So I think the water dispersed in the acetone, but it also froze, so I'm pretty sure what we're seeing in there are tons of separated individual little ice crystals. I'm going to pour some more in. It just kind of builds up on the sides here. Weird, slushy. I'm guessing that's a mix of acetone and water. It certainly smells like acetone. Ooh. That is spraying everywhere, isn't it? Now we've tested making a cooling bath that takes acetone down to over 100 degrees below zero. Let's see what happens if we take dry ice and put it in our backyard foundry. Dry ice is composed of carbon dioxide, so it's possible that as it heats up and starts turning into a gas, it will put out the flame. That's one of the things we're going to find out. And if it doesn't put out the flame, let's see what it will do. Our foundry's nice and hot. Let's see what happens when we put in our dry ice. Until they're glowing red hot, and then touch that directly to the dry ice. All right, let's see what happens. Well, not a lot, really. Not a lot happened. I thought it would do a lot more. I thought the red hot metal might melt its way through the dry ice, kind of like it does with normal ice, but it just cooled off the metal and barely left a dent in the dry ice. Let's throw the rest of it in, see what happens. all of our dry ice is gone, it didn't put out the flame, it didn't put off a lot of vapors like it does if you put it in hot water. It just sort of sublimated into nothingness. That whole block took about 10 minutes to disappear in our furnace, which is much faster than if you just left it sitting on the counter, but it's not very enjoyable. After putting all that water, I'm sure it was able like that. Here it goes. On fire, but it's freezing cold. Like, if I touch part of it, it's very cold to the touch, but it's on fire. It's freezing cold and on fire at the same time. That was freezing my hand and burning my hand. Different parts of my finger at the same time. Oh, and now our acetone is all just running off and pouring off. And we've used this brick for some colored smoke powder before, and the acetone has been pulling that off of the brick, and so we're getting this pink stain as it runs. There you have it, 2 experiments using dry ice. One, a method of making an extremely cold liquid bath using acetone. The other, putting dry ice into our backyard. With the acetone bath, we were able to supercool rubber and produce, and both of them became very brittle and lost all their elasticity when they were completely frozen in the acetone. With the dry ice in the foundry, it turned into gas faster than it normally would if it were just